Now that we know how to find our vertical asymptotes, how to find our holes, and how to find our horizontal asymptotes, now we're going to graph these functions. And guys, the truth is, when it comes to graphing rational functions, I always use my calculator. I always graph it, and then I go to my table of values, and I look at where x can exist to help have an idea. But sometimes when you have a picture of the graph, you can't always see those holes. So it is important to know how to do this by hand. So our first function, function g of x, is x plus 1 over x minus 2. So to review, we need to figure out first our vertical asymptotes and our holes. So in this function, there are no factors that cancel out. So because that's the case, then I actually am not going to have any holes. But I do have a vertical asymptote. I have a vertical asymptote located at x is equal to 2. If I plug 2 into that factor, 2 take away 2 is 0, and I am not allowed to divide by 0. So I have a vertical asymptote at 2. So I'm going to go ahead and draw that. I'm going to draw this vertical line located at x is equal to 2. So now my horizontal asymptote. So again, we have to compare our degrees of our top to our degree of our bottom. So in this case, my degree of the top is 1. My degree of the bottom is 1. So I have equal degrees. So when that happens, you've got to compare your leading coefficients. You've got to set up a ratio. So I have an asymptote located, so the leading coefficient of the top is 1. The leading coefficient of the bottom is 1. 1 over 1 is 1. So I have a horizontal asymptote located at y is equal to 1. Setting up these lines just helps give me an idea of what the function's going to look like and where it's going to be shifted to. And the truth is, just like I do with anything else when I'm graphing, always use an input-output table. So if you go back to Unit 1, plug numbers into x and numbers into y. So if I plug in negative 2 into x, negative 2 plus 1 is negative 1. Negative 2 minus 2 is negative 4. Negative 1 over negative 4 is positive 0.25. Okay, if I plug a negative 1 into x, negative 1 plus 1 is 0. Negative 1 minus 2 is negative 3, but 0 divided by anything is 0. If I plug 0 into x, 0 plus 1 is 1. 0 minus 2 is negative 2. 1 over negative 2, or negative 1/2, or negative 0.5. Okay, you get the hang of it. So when 1 goes in, negative 2 goes out. When 2 goes in, oh hey, we're undefined there. And when 3 goes in, 4 comes out. So now I'm going to graph these points. Undefined there. And it's negative 2. And again, I would definitely look at this function in the calculator, see what it looks like. But when I go and graph it, ta-da, here we are. Whoops, we can't touch that line. And there is a picture of my graph. Okay, so now the next example. So x squared minus x minus 2 over x minus 2. Okay? Before I do anything, I want to factor my function. So what does this look like in factored form? So x plus 1 and x minus 2. And then x minus 2 is in the denominator. And so my denominator completely disappears. Those factors of x minus 2 cancel each other out. Ironically, when this simplifies, it simplifies down to the function x plus 1. So if these two functions are the same, does that mean when I graph this that it's going to be a line? I don't know. All you can do is take my word for it or graph it in Desmos and see for yourself. So because those two factors cancel each other out, I have a hole located at x is equal to 2. So I'm going to go and to 2, and I need to put a hole somewhere on this line. Well, how do I figure out where that hole is going to be? Well, if I take 2 and I plug it into the simplified form, so
it's not reading this.
So 2 plus 1 is 3. So I actually am going to have a hole located at the point 2, 3. Okay. So how do I get my other points? Well, I got to go back to these asymptotes here because everything in the denominator's canceled out and I don't have anything left. Well, I have no vertical asymptote. So what about my horizontal asymptotes? Well, the degree of the top is 2. The degree of the bottom is 1. Since the top is bigger than the bottom, hey, guess what? I have no horizontal asymptotes. So what does that mean? That means that I am going to graph this line. I'm going to graph a line that has a y-intercept of 1 and it has a slope of 1, so rise 1, right 1. And when you look at this on Desmos, you don't necessarily know that you've graphed a rational function because it's a line. The only reason why I know it's a rational function is because of what I had to start with. And that the graph doesn't exist at 2. So my domain of this function is everything from negative infinity to 2, and then from 2 to infinity. So, back to that original question. Why did my shirt say, can't touch this? What is it exactly that you can't touch? Well, in this function, I have this vertical asymptote at x is equal to 1. So I cannot touch the function, or I cannot touch that asymptote at x is equal to 1. There's that vertical asymptote. So I hope you guys have learned something today. When you get to Math 3, you're going to be learning all of this again in Math 3. So hopefully this has been helpful. Make sure you're getting your notes, and then you're going to have a review this week, and then you're also going to have a test this week. And graphing functions will be on there. And the calculator is always useful, but Ms. Green might ask you where the holes are. So make sure you know how to find the holes, how to find the vertical asymptotes, and how to find the horizontal asymptotes. Miss you guys. Hope to see you soon.